Okay, grade 8. This video is lesson 6 in chapter 9, analyzing data distributions. Okay, you need to know that distribution and symmetric. Okay, write this in your notes. The distribution of a set of data shows the arrangement of data values. Up to there. This sentence. Okay, make sure that is in your notes. Okay. All right. So when we are analyzing data, we need to do it in two different ways. You either use the shape. You must use the shape, and you must do the center and the spread. Okay. So actually, I should say 3 ways: shape, center, and spread. Okay. But center and spread go together. Shape goes by itself. So when you're analyzing any data or any distribution, you must talk about the shape, and you must talk about the center and the spread. Okay? That's what I said here. When you're talking about the shape, you should mention 5 things. You should talk about whether the distribution is symmetric or non-symmetric. So one of them is 1. If the data has a peak, if it has a high point, like here, see? The data has a peak. This is the highest point. Here is the data. Here in this distribution, here is the peak. Okay? If there are any clusters, if the data has a cluster, if the data has outliers. Remember, an outlier is a data point which is much greater or much less than other data in the set. So if it is very far away to the left or far away to the right, away from most of the points, then that's an outlier. Okay? And if your data has gaps, if there's a space, like here, see? There's a space here. There is no, 13 has no point. So that means this is a gap, okay? Like here, there's a gap because there's no data between 84 and 90 something. What is this? 94. Yes, between 84 and 94, there is a gap. There is no data there, okay? So you must talk about whether it is symmetric or whether it is non-symmetric. You must talk about a peak, cluster, outlier, and whether it has gaps. How does a symmetric a symmetric distribution look? Like this: equal parts in the middle. If you draw a line in the middle, the left side should look exactly like the right side. In non-symmetric, it is skewed. Skewed means all the data is on one side. Most of the data, not all. Most of the data is on one side. So you can be skewed to the right where your mountain is to the right. And you can be skewed to the left where your mountain is on the left, okay? Like that. So when you're describing non-symmetric, you say the right side is taller than the left side. Or you say the left side is taller than the right side. The left side. This is left, the middle is here. This is left, this is right. The middle is somewhere here. This is left, this is right. So you draw your middle line and you describe using left and right, okay? All right. Now, when you're describing about the center and the spread, you should know the shape first. So, first you must look at the shape. The shape is what determines which center and which spread you're going to use, okay? If your data is symmetric, then you will use the center, that is the mean, and you will use the spread, that is the mean absolute deviation. So when your data is symmetric, you use the mean and you use the mean absolute deviation. When your data is non-symmetric, you use the median and to describe the center, and you use the interquartile range to describe the spread. How do you find the interquartile range? You minus Q3 with Q1, or you minus Q1 from Q3. What is another name for Q3? Third quartile. What is another name for Q1? First quartile. What is another name for Q3? Upper quartile. What is another name for Q1? Lower quartile. So in your question, you will see either one of these being used. You should know where to get them and how to get them, okay? Now, remember, non-symmetric, median, interquartile range. Symmetric, mean and mean absolute deviation. Now, let us look at examples. So I have a few examples I did. Actually, I did two. All right, let's look at this one. We are analyzing, this is the question, yes? So this is the distribution they gave us. And they told us to analyze the data, analyze this data distribution. So I looked at it and I saw it is non-symmetric. Non-symmetric. Why? Because the left is taller than the right. And that's what I wrote. The data is non-symmetric because the left side is taller than the right side. This data has a peak at 12. I go to 12, that's the highest point on my data. This data has a gap between 14 and 9. There is no numbers between 14 and 9, so that is a gap. This data has an outlier at 19. 19 is very far away from the rest of the points. See, the gap is very, very big, okay? This data has a cluster from 10 to 13. Yes, most of the points are here, see? So there is my cluster. So I've analyzed the shape using 5 different statements, okay? Now I need to describe using the center. So what center do we use when we have non-symmetric? We use the median. I arrange all my data from least to greatest. So how many 10s do I have? 3. I have 3 10s. How many 11s do I have? I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. How many 12? 6 of them. 1, 2, 3, 4, 5, 6. I have 6. 1, 2, 3, 4, 5, 6. How many 13s? I have 3 13s. 1, 2, 3. 3 13s, 1 14, and 1 19. Now I need to find my median. 10 goes with 19. 10 goes with 14. 10 goes with 13. 11 goes with 13. 11 goes with 13. 11 goes with 12. 11 goes with 12. 11 goes with 12. 12 goes with 12. I am left with 12 in the middle. So then I will write here my sentence. The data is centered around the median 12 states because this information is about states. You see, the number of states visited. So the data is centered around the median 12 states, like that. 12 states that are visited, that were visited. Okay? All right. Now I need to find my interquartile range. I found my median. I draw my boundaries. And I start again. 12 goes with 10. 10 goes with 11. 10 goes with 11. 11 goes with 11. So this is Q1. 12 goes with 19. 12 goes with 14. 12 goes with 13. 13 goes with 12. I am left with, this is Q3. So I come here, Q1 is 11. Q3 is 13. So 13 minus 11 is 2. Then I write the spread of the data is the spread of the data around the center is 2 states. Is 2 states. And this will be my answer for here. Remember, you did your units. And where do you get your units? From your question, from your distribution, from your data. Okay? Let's do another one. So here is my data. My data is talking about tennis players. Now, when I look at this data, it is symmetric. So I need to analyze the data distribution using the shape. Then I'll say this data is symmetric because the left side looks like the right side. This data has a peak at 28, 29 because here is the highest point. 28, 29, and 30. So in a symmetric distribution, the mean, the mode, and the median fall at the same point. Like in this picture. Okay? The mean, the mode, see? So this is a symmetric distribution. Please draw it. And the mean and the mode and the median all are together on this line. See? This is the center of your graph or the center of your distribution. Okay? Something very important. So in a symmetric distribution, the mean will equal the mode, which will also equal the median. Okay? All right. Also another thing, remember you can have more than one peak. Okay? Either all of them are in one place or in different places. So here, one peak, or here you have 2 peaks. Do you see that? When you have 2 peaks, it's because you have more than one mode. Okay? 2 different modes or 3 different modes like that. So here, the reason why you have 2 peaks is because you have 2 different modes. Draw the picture and write that. And label. This is peak. And this is peak. And the reason why is because you have 2 different modes. I don't think symmetric data will ever have a gap. Yes, symmetric data will never have a gap. Never. Because you need all the points, all from there. There is no space in between. Okay? So, having said that, the data does not have a gap. There is no gap. There's no numbers missing. And the data does not have an outlier. Okay? Yeah, the data will not have an outlier because the numbers will be continuous. See? Because you don't have a gap, you don't have an outlier. When you have a gap, you have an outlier like that. Sometimes, not always, sometimes. Okay? All right, the data has a cluster. Yes, most of the points are here. See? Here. A lot of points are here. Okay? Between 28, 29, and 30. Around. I should use the word around, not between. Around. Around 28, 29, and 30. Now, because this is symmetric, we will use the mean. What will we do? We will add all these numbers in our data set and divide by how many they are. So I wrote them. We have 25, 26, 2 of them, 27, 3 of them, 28, 4 of them, 29, 4 of them, 30, 3 of them, 4 of them, 31, 3 of them, 32, and 33. If you can look at your data, see? We have 125, 226, 327, like that. And you have to write them. So you write 25, 26, 26, 27, 27, 27, like that. You must repeat them however many times you see these stars or dots next to your name. After I added all my numerator, I got 696. How many numbers are in my data set? So this is 1, this is 2, this is 3, this is 4, 4, 4, this is 3, this is 2, this is 1. So 1, 2, and 3, that makes it 6. 1 plus 2 is 3, 3 plus 3 is 6. So I have 6 over there, 6 on this side, and then you have 3 4s, which is 12. 6 plus 6 is 12, 12 plus 12 is 24. So in my data, I have 24 data points. So 696 divide 24, I got 29. And since my unit is tennis players, I wrote 29 tennis players. Then I wrote the data is centered around the mean, 29 players. Why did we do the mean? Because our data is symmetric. Okay? Now, after we do the mean, we need to do the spread. So make sure you show your work. You write your numerator and denominator. You divide. This is your answer for the mean. You box it and you write your sentence. The data is centered around the mean of 29 tennis players. When you write your number, you must write with a unit. If you don't write with a unit, your answer is not correct. Okay? After we find the mean, we need to find the mean absolute deviation because that is the spread. The spread when your data is symmetric is the mean absolute deviation. So we subtract the mean, which is 29, from all the values in the data set. Now, I didn't want to write 26 2 times and 27 3 times. That's wasting time. I can multiply because the answer will be the same. So I'll multiply by how many times 27 is in my data set. I will multiply by how many times 26 is in my data set, like that. So I found the absolute value. So 25 minus 29 is -4. Find the absolute value of -4, which is 4. So I circled because I know I'm going to use it, okay? That's the reason why I circled. 26 minus 29 gave us -3. Absolute value of -3 is 3. Why am I multiplying by 2? Because there's 2 26s in our data. And then I repeated for 27, I got this. Then I repeated for 28, I got that. Then I repeated all this. See? I repeated for each of the data in my values, in my data set, okay? Now, after I added my numbers, which is 4 plus 6 plus 4 plus 0 plus 3 plus 6 plus 6 plus 4. I divided by 24. Why? Because there is 24 numbers in my data set. Don't count this and then divide by this. No. Remember you multiplied. Remember you multiplied. Don't forget that. Otherwise, you have to do each one by itself, which is wasting time. Remember, this denominator must be the same as the denominator for the mean. They must be the same. They cannot be different. Okay? So when I added my numerator, I got 39 over 24. And then I got this. So now, I said, here, I'm going to round to the nearest whole number because we are talking about tennis players. Tennis players cannot be a decimal. There is no human being that is a decimal. So I have to represent it as a whole number. So your data reminds you how to round. You need to ask yourself, can I use a decimal? Can I use, does it make sense for me to use a whole number like that? Those are decisions you should make according to the data. So at first I had forgotten, then I said, no, this doesn't make sense. So that's why I said my answer has to be 2, okay? Then I wrote my sentence, the spread of the data around the center is 2 players, okay? Like that. Please don't forget, if you do this method, you have to remember that your denominator is the same as the denominator that you use for finding the mean, okay? Do example A and example B, and we'll talk about them tomorrow. And make sure you finish your Aleph. Okay, bye.